I was looking at the agenda. I'll have the names. Okay. So I have a minute after the hour. Should I give it another more minute? One more minute? Hello? Christian, you're on mute.
Yes, I'm on mute, but 1 more minute and then we can start, yes.
Okay, I'll keep it on. Cool. Well, hello. I'll start now. And good morning, good afternoon, and good evening to everyone here on our second Joint Initiative Council webinar. We had one Eastern in U.S. Eastern time in the middle of the night, and this one is for the other side of the world. And I want to thank you all for attending, and we'll start the proceedings. So our first, I'd like to, I'm sorry. Let's go over some of the logistics for the webinar, and we're talking today about a very important topic and one that we're all living today. That the entire world is, vaccinations, and it's something that everybody's thinking about. Everybody is working on, and it's a professional issue. And the whole idea of being able to take care of our lives with by being inoculated and having vaccinations and being able to report that. We put a story together that'll help you understand what we're trying to do, and we're going to talk about all the standards groups that are involved in both JIC and this initiative regarding vaccination. And I'll go through some logistics for a second here. So you'll see that everybody is on mute. That and what you can do is post your question in the Q&A facility, and you can of course show your approval, thumbs up, thumbs down, or whatever other thumbs you want to use. At any time a question or a comment can be shared in the Q&A period. We have some experts that are online in addition to the presenters, so we'll try to answer them along the way. And just check the Q&A facility for that. If you look at it, if you hover your mouse over the screen, you will see the options bar, and you can select the Q&A area and enter information in there. You can also put in the comment or question or engage in a conversation with your comments, and we will try to answer them along the way, so keep an eye in there. So let's start with what the JIC is. So the Joint Initiative Council was established in 2008. We find that before that period, we had some informal meetings, but in 2008, a number of SDOs came together as the Joint Initiative Council, and we wanted to create a collaborative framework of health informatics standards to enable digital transformation based on information interoperability. And that's a very important aspect of our work. All of these standards fit together. They're all in different domains. We'll be talking about them, but they fit together so that we can have interoperability and computability, if you will. The data can be shared reliably. What the JIC was formed to foster collaboration between standards and clinical communities worldwide. And one of our very important areas and goals in getting together is to support high quality health services to individuals, communities, and populations. That's a very important theme that runs through all of our work, and was why we got together in the first place. And over time, as we've been doing work in this area in inoculation and vaccination, is another area. You'll see how many different standards bodies are involved in order to bring that about. Our mission of the JIC is to promote interoperability and seek to avoid overlaps and inconsistencies. We look at all the work that everybody's done, and we're always looking at gaps and overlaps. So we want to fill the gaps, and we want to make sure that there's not overlaps, and most importantly, that we don't have inconsistencies. We want to be able to achieve greater coordination and consistency of health informatics standards development. And we have a communication function also to develop global awareness of the importance and potential contribution of health informatics standards. And when I think about informatics, especially as chair of TC 215, which is titled Health Informatics, it's about computability, if you will. Another part of our mission is to share information transparently. We're always meeting, sharing information, sharing drafts, working together. It's very important that we're transparent. All of our standards development organizations have open, membership or rules, if you will, so that we have balance and we're transparent in our sharing of information. We also, part of our mission is to provide a gateway to support and provide advice on health informatics standards collaboration and for reporting progress toward achieving a coherent set of standards for informatics. And of course, we want to promote the development, adoption, and recognition of relative health informatics standards as international standards. As any organization, we want to have our clear core values. We're customer focused. Our stakeholders are our customers, our SDOs are our customers, our subject matter experts are our customers, the governments and regulators are involved in our activities, are part of our customers, and we're focused on their needs. We also focus on facilitation, where we can be that arm's length middleman when necessary, especially when you're talking about, filling gaps and eliminating overlaps. Another value is openness and transparency, flexibility. We don't want to be stuck in our ways. We want to listen and learn as all of this work progresses. Another core value is innovation and quality improvement. We want to constantly get better. And you'll see if you look at our work over the last 12 plus years, we're doing more and more work, more and more coordination. One of the things that we've learned is that it's easier to collaborate up front than it is to harmonize after the fact. So we want to make sure that that is first and foremost and at the core of all of our activities. And of course, everybody has their opinion, and you're entitled to opinion, but a core value is respect for professionalism and to be open about everybody's background and perspective and interests. The members of the JIC are listed here. We have 9 different standards development organizations: CDISC, SEN, Health Informatics TC251, DICOM for imaging, GS1 for supply side, HL7 for transactions, IHE for profiles, ISO TC215, which I chair, for health informatics, LOINC, and SNOMED for terminology. And just to put some names and faces with each of these organizations, these are the lead points of contact for all of our different SDOs that are involved in our activities, and they'll be part of the record. And this is quite a close-knit community, and I'm sure most everybody knows most everybody. So please stay involved and engaged, and feel free to contact any of our leaders in all of this work. So what we've done today for our webinar is that we're focusing on the vaccination journey. We've made up a story, a use case, if you will, of Adelle. We created a avatar person, if you will, called Adelle, and we'll talk about her vaccination journey from getting the first COVID vaccine to storing the information to being able to share it appropriately and with trust and confidence, which we'll talk about, and then of course to be able to show that there's kind of a vaccination passport, if you will. To perform that journey, there are a number of different standards and interactions that are composed of that journey. We're going to talk about implementation. Here we're going to do the US perspective. We have capture data. And by the way, we're going to do implementation last. I'm sorry, we're going to capture data. We have GS1, LOINC, and SNOMED to document her vaccination process. We're going to manage data. HL7, ISO, and SEN are going to talk about documenting Adelle's health record and immunization file. Very important aspect of this, of course, is sharing the data. What good is a write-only memory, if you will? We want to be able to share this information among and between all of the organizations and parties and stakeholders that need that information, from the patient to the venue where they might want to be able to show that they've been vaccinated. And an important aspect of that shared data is work that we've done with CDISC, IHE, and HL7 in the area of the International Patient Summary. And that's an effort where we're using a consistent way to share patient information across boundaries, disease doesn't know boundaries, neither should cures, neither should the data. And then the last role of standards and interactions is trust. Obviously, this is very important, and we're going to talk about that from the perspective of ISO, SEN, and HL7. that all along the process, trust requires authentication, validity, identification, provenance, and other things that we're going to talk about in that section. The speakers in each of these areas are for capture data. We have Marjorie Rollins from LOINC to manage the data. We have Beverly Knight from ISO to share the data. We have Derek Ritz from IHE International. For trust, we have Gary Dickinson from Health Level 7. And the last segment, which is implementation, we have Nilima Karapanini, who is from MITRE Corporation. What happened to my C's? Oh, I skipped this one. I'm sorry. There was one more slide that I skipped by. And in the program today, we have our 5 C's of digital health standards. So we have care guidelines, specifications related to content, coding, communication, and confidentiality. So here's the roles again. Here are the program developers. And that is our intro. I put this slide up so that you can see that we have a lot of different social media and other mechanisms for sharing information for the community at large and other standards development organizations to see what we're up to. So, you know, look at us in LinkedIn and Twitter and all the other social media outlets that we're very active in supporting. So with that, I'd like to turn it over to our first presenter, which is Marjorie Rollins from LOINC. Marjorie?
Great, thank you. I'll share my screen.
Very good, and I will stop sharing.
Okay. Just get things set up here. Okay, so hello everyone. Let me first apologize for not being on camera. My internet is temperamental and it's probably best that I remain off camera. Again, I am Marjorie Rollins. I'm the Executive Director for LOINC and pleased to be leading this part of the session on capture as it relates to best practices to identify and code vaccination information, or more broadly, immunization data. In this session, we'll discuss the role that terminology standards like LOINC and SNOMED and other data standards like GS1 play in capturing immunization information, as well as their roles in facilitating interoperability across the care continuum. We will start with LOINC, and I'd like to begin with just a little bit of background for those of you who may not be familiar with LOINC. LOINC is an acronym for Logical Observations, Identifiers, Names, and Codes. We describe it as the global standard for identifying health measurements, observations, and documents, including surveys. LOINC was established in 1994 by Dr. Clem McDonald, who was a Regan Street researcher, who is now with the National Institutes of Health and who many of you may know. And it was developed out of a need for a universal language for observations for electronic data exchange so that laboratories and other entities could communicate orders and results to hospitals, provider and physician offices, and payers, et cetera, who use the data for clinical care and care management purposes. LOINC has grown in scope and content since its inception in 1994. The initial focus was laboratory observations. Clinical observations came along in 1996. And today it includes both laboratory and clinical concepts that are used when someone orders or needs results for health measurements and observations. And today, LOINC has approximately 100,000 codes. It is maintained by the LOINC Health and Data Standards program at the Regenstrief Institute by a very dedicated LOINC team who are very busy working on the June release of LOINC as we speak. So let's talk about where LOINC fits in capturing immunity data. There's an array of content in LOINC that exists to support a number of use cases, including ordering tests and observations, collecting information, and generating and reporting results. And together, these pieces of content are important in describing the facets of the clinical process that are necessary to paint the clinical picture as it moves through the interoperability continuum. For the purpose of today's discussion, we'll focus on three main categories or content domains for LOINC. Laboratory LOINC, which includes laboratory tests, whether performed in the hospital or in an outpatient setting, in the provider office or a public health facility, or by the patient at home, which we know is very relevant today in COVID times. Next is clinical LOINC, which includes all types of measurements and procedures and documents and other clinical information not found in the laboratory domain. More specifically, things like anthropomorphic measurements like BMI and eye color and head circumference and procedures like cardiology and ultrasound. And finally, there's standardized survey instruments and documents, which are actually a part of clinical LOINC, but are worth calling out separately here. And these areas include things like patient-reported outcomes or patient-reported outcome measures, also assessments that are completed by the provider, as well as content like clinical forms, such as those that would be required by a local or federal government. Drilling down a bit more to look at some immunity content in LOINC, laboratory LOINC has terms to represent things like testing for antibody titers. That's just one example. There are many laboratory tests in LOINC, including those for, assessing immunity, et cetera, for a variety of purposes. Examples from clinical LOINC include terms to describe, for example, an immunization series, such as the number of doses in the series or the actual dose number itself. Clinical LOINC also has content to describe details about the patient, such as the patient's age or their occupation, which may be relevant in determining eligibility to receive a vaccine. And then the survey section of LOINC includes administrative terms that might be found on a form to help identify a patient or convey the name of the caregiver, such as the nurse who is caring for the patient. It's important to note that the core essence of LOINC is its concept model or structural mechanism that facilitates the exchange of data electronically, thereby making that data more portable. And the concept model also facilitates a data exchange in a manner where the semantics or the meaning of the data is preserved, and the data can be interpreted consistently, even if displayed differently by different organizations. And that's the point of this graphic here. These 5 hospitals display the measurement of systolic blood pressure very differently. However, because they each standardize and exchange that information using the same LOINC code, the meaning is preserved. And this fundamentally functionality imparted by the LOINC concept model is fundamentally critical to, comparing and analyzing data when these data are pulled together and analyzed against national norms, for example. And one last point about immunity data in LOINC, and that is that during the pandemic, standards development organizations, terminology stewards, such as the Regenstrief Institute and LOINC, SNOMED International, the National Library of Medicine and elsewhere throughout the world worked tirelessly together to ensure there was content, including immunization content, in their respective terminologies to address the needs of the pandemic. The collection of that work for LOINC can be found in one place for convenience on the LOINC website. And you can find that at loinc.org if you're interested. Turning to SNOMED CT, it is a clinical terminology that is owned and stewarded by SNOMED International and is designed for use in electronic health records, specifically in representing and capturing clinical detail recorded during the course of patient care. And the value of SNOMED is best appreciated when it is implemented and used as part of an application that is associated with an electronic health record. Just as it was important to highlight the concept model for LOINC, it is critical that we also highlight the concept or logical model for SNOMED, which provides the fundamental structure of SNOMED and essentially provides the framework for how to use SNOMED for important use cases like data retrieval and analytics. Drilling down a bit more to look at SNOMED in the context of capturing immunity data, across its numerous hierarchies, SNOMED can represent important concepts like the indication for prescribed medications, dosage, route of administration, and target site, which are all important in the context of vaccinations. There are a number of global vaccination initiatives that SNOMED is committed to supporting when the relevant content is in scope for SNOMED. And examples include the Digital Green Certificate and the WHO Smart Vaccination Certificate. And in 2019, SNOMED International introduced the Global Patient Set to support the sharing of patient information encoded with SNOMED CT, also known as the GPS. It is a collection of reference sets tailored for a variety of clinical domains, and each domain has an associated technical specification. And then, since we're discussing immunizations and vaccines where product labeling is important, we need to highlight GS1, which is a not-for-profit global standards organization that is best known for barcode standards. And these stats on the lower part of the screen demonstrate the widespread adoption and use of barcode standards. As I mentioned earlier, it takes a collection of terminology standards, including clinical vocabularies like LOINC and SNOMED CT, and administrative code sets like ICD-10-CM and CPT, to optimally capture immunity data required to support use cases across the interoperability continuum. Additionally, as we just discussed, standards that facilitate product identification, such as GS1, are also important. More specifically, by scanning the GS1 barcode, a system is updated with important information about the product, such as lot and batch number, using unique identifiers, and thereby obviating the need for manual entry. And if a drug, such as a vaccine, is modified to accommodate a variant, for example, the standard is structured such that the modifications remain associated with the brand name for that drug. That's important. So let's look at the narrative for Adelle, a 48-year-old woman who is immunosuppressed because of a prior kidney transplant. She is eligible for the phase 1 group to receive the vaccine because of her medical history. She presents to the clinic and receives a number of assessments to reconfirm her identity, her eligibility to receive the vaccine in phase 1, and that she is asymptomatic for COVID-19 before receiving her vaccination. Once she receives her vaccination from Nurse Charlie Delta, she gets a summary of her clinic visit and an appointment for a return visit for her second shot. We can capture this narrative with LOINC, SNOMED, GS1, and other standards. We'll just focus on those 3 that we just discussed. So these are the shaded areas that are components of a narrative that can be captured or supported by LOINC. These are the areas that can be captured by clinical LOINC. These are the domains for the survey section of LOINC, and this is what's covered by the laboratory section. So that's the representation from LOINC. Looking at SNOMED CT, these yellow areas reflect the components of the narrative that can be captured by SNOMED. And then these are some areas that can be captured by GS1. This looks a bit confusing, but this is what it takes and is required. This is the full coding with all of the standards. Again, I reiterate that there are a number of standards that are required to represent immunity data to support use cases across the interoperability continuum. So in summary, terminology and supply chain standards are determined by country-specific digital health policies. Terminology standards are a part of the interoperability solution and must also coordinate with other standards such as HL7, HL7v2, the CCDA, FHIR, et cetera, WHO classifications, and other standards as well. This use case reflects what already exists and can be captured in EHR systems in relation to vaccination and immunity data. The terminology stewards and SDOs have demonstrated that they can add new content as the needs arise, as we witnessed and experienced during the, especially at the onset of the COVID pandemic. And collaboration is required and will need to be continued to develop methods to define or methods to capture things that cannot currently be captured. I want to definitely make that point. And terminology development is underway to support a number of immunization initiatives currently underway, including those from the EU, the WHO, and the CDC in the US. So on behalf of my colleagues, Christian Hay and Jane Miller, I want to thank you for the opportunity to present this section of the panel. Thank you.
Thank you, Marjorie. Thank you very much.
Thank you. Welcome.
And now we're going to change dimensions, if you will. Once we've captured the data, we want to be able to manage the data. And Beverly Knight from ISO is going to lead us through that discussion.
Hello, everyone. This slide deck just represents a collaboration, just so you know, right up front between myself, Rob Housam, and Giorgio Cangioli. So when I refer to we throughout this presentation, that's the we that I'm talking about. So today's presentation, this managed data piece, is really about the structure. I'm passionate about the structure. I'm a terminologist by background, and yes, I'm certainly understand the value of the terminologies, but and all of the components are important, but my recent experience, I think, working with stakeholders is getting that structure right from the beginning is so important, because it does make the capture, the documentation, ultimately to share, and even more importantly, do analytics and other features are so important. The challenges aren't new. I think all of us that are working in this area have been working on all of these challenges, what the information is to be captured, how to provide the context, how to assure consistent representation, and how to enable the reusability. But the one challenge that I think I've seen, my experiences, showed the biggest problem was the first one. What is the information to be captured? Public health and immunization is a very complex area, and the stakeholders who are working with the technical folks who are trying to come up with solutions often have a hard time understanding each other, because there's so many nuances, and which are the relevant ones? Can you separate it by use case? Like, how to do this is a challenge. So I just wanted to highlight the challenges and the problems that we hope to solve by this goal. This is the we idea here of an harmonized ecosystem of cooperating standards and solutions, and SDOs, I might add. And it's not to say there's been no cooperation, there's been no collaboration. I think we're all going at this, at different timelines, and those all have to be respected. But I do think a goal of trying to align would be a goal that would be worthy of thinking about. So this presentation, I'm not expecting to convert anyone here. I think all I'm hoping for is to introduce you to this notion. And if you're interested, be happy to elaborate beyond my 15 minutes here. So obviously we need to focus, solutions that can solve the conceptual, logical, and implementable layers or levels that are required for all digital health, but in this case, immunization. And I've provided a bit of a snapshot here for you for the players, the projects, the products, assets, standards that are all in play. Now, I don't have them all mentioned, and I apologize if anybody's offended, but I did try to capture that others there to sort of capture it all. But we're going to focus on the blue box, because that's where we have the data elements, the common structure that I think is needed. So we have ISO IDMP, that's the identification of medicinal products, which is a core standard that we believe has to be a strong underpinning of this set. Must align and include IPS, International Patient Summary. And the new one that is being worked on right now, and I'm leading, ISO TS 5384, which I'll speak about in more detail, but it is the data elements for documenting and sharing immunization information. So what does harmonized ecosystem look like? Well, to me and us, it is that alignment of the SDOs, the initiatives as best as we can to come up with and use a common implementation independent level set of data elements, similar to what was done for IPS, but one that works for immunization. Context is absolutely required for capturing and sharing data to provide that understanding for all participants who are working on an initiative that include the public health and the technical stakeholders, so that the data can be used and understood seamlessly. I highlighted at the beginning the challenges I've observed between ensuring that the words that you use in your data elements, the descriptions, are fulsome enough that it isn't just a technical person that can understand them, but also business stakeholders, because they need to use it. And the challenges is some of the data element descriptions, and again, this is not a knock. I think we're all evolving. We've observed some lessons that we're trying to, solve in TS 5384, but there are some data element descriptions in FHIR that are ambiguous, and they really leave it up to the implementer to fill in the gaps. And that ultimately leads to solutions that are inconsistently implemented. And not only that, it takes longer for them to get to a happy place to get the specification in place. So my classic example I like to use is manufacturer. Most standards that I've seen use manufacturer, but in the real world, there are two ways of looking at this. There is the pure manufacturer. So this is my terminology, just focusing on the details here. And the ISO IDMP definition, which is what we're using in 5384, is it's the organization that holds the authorization for the manufacturing process of the product, as opposed to the market authorization holder, or MAH. That's the organization that holds the authorizations for marketing the product in a region. So in Canada, that's Health Canada. They approve drugs, including vaccines, for use in Canada. The MAH and the manufacturer are often the same, but not always. And that's where it leads to challenges. And what's on the label, at least in my experience in Canada, is always the MAH. So the examples of challenges with stakeholders in this is that I was working with a group of stakeholders who said, like, I need more codes because I've got this product and on the vial, it has manufacturer A, but in my system, I'm seeing manufacturer B. Well, really, this is one and the same, but it was the solution that was the challenge that led to this. And they had been asking and requesting more codes. And that just takes us to a very unhappy place, and it doesn't work. So these implementation independent models do provide that common understanding of the data that's required. However, they don't assure technical interoperability. So that's where we stop. Anyhow, patient summary. Here's a wee summary, snapshot of it, if you will, for those that may not be as familiar with it. It is the result of a cross-SDO collaboration that resulted in a data set, in other words, a set of data elements that are reusable beyond a specific domain or jurisdiction. HL7 FHIR and other folks came along and came up with implementable specifications based on that data set. SNOMED GPS is also involved in all of this. So that was a really good success story. And I think you can begin to see where I might be hinting that maybe an immunization international patient summary might be an idea. And this slide sort of takes that home, where you can see on the left, patient summary focused on certain categories. They had the summary level of vaccinations and those other things. But what's needed, as I understand, by the way, IPS, there's a bit of a growing interest in expanding or going with other scopes that leverage the base IPS. And so immunization, I think, is a really good candidate to do that, whereby what's in the middle is sort of elaborated on with additional data elements not present in IPS that could ultimately translate to something like a digital certificate. So that was the IPS component that I just gave you a snapshot on. Now we're going to look at the data elements for the identification exchange of immunization data, 5384. This provides a base set of data elements that are fully elaborated. It leverages the methodology used by the IPS, which provides awesome, fulsome descriptions, requirements, considerations for use, and more importantly, even purpose. So an example of purpose is sex and gender. I am getting more enlightened about that with the recent HL7 work on sex and gender, but I think it's a good example here. So in Adelle's use case here, did we need her sex or gender for identification of her? Or is it needed because the registry where her information will be stored needed it for clinical reasons? And the answer to that question means you might need a different value set to support that. And that's super important. So you see where the nuances come into this and why all that fulsome elaboration is so important. The other thing TS5384 does have right now are 7 use cases. And what we've done is each use case, we've taken from the base the relevant data elements and showed which ones you need for which use case. And one more thing that it also does is it shows we describe or provide in the considerations the data elements that need to work together, because in some use cases they do and some they don't. So that's where a lot of these nuances are. So our data elements aim to align with IPS, IDMP, the SNOMED allergy and intolerance model. I'm working on that one. And this new information from sex and gender modernization at HL7. So all of that we're hoping to align. And when I say align, what that really means is, for the most part, we're taking the descriptions that those folks have in their standards already. Why reinvent it? I don't believe there's any descriptions that we're making any tweaks to. What we are elaborating on are the nuances for vaccine information in the considerations, requirements, purpose, and all those other things. We've done our best to align where possible with the WHO data set. There isn't an exact map, but I think we're close enough and it's not bad. The other thing we plan to do, and this is Giorgio's thing, is to facilitate a consistent implementations to make it easier. We're going to provide a representation of the data elements as a FHIR logical model, and also plan to provide a mapping to some specific HL7 FHIR spec or specs. So getting back to Adelle's journey and what this really means to her. So she expects when she shows up, makes her appointment, whatever it is throughout the thing, that the systems have got themselves structured properly so that her information can be used. It can be sent to the registry. And if she needs a booster somewhere later, 6 months from now, as might be determined, they can get in touch with her. That her information, again, from in an ideal world, that is sourced from a registry and available in a solution like a passport, a smart vaccine certificate that allows her to visit and travel and visit her family, that she can get that. So all of that, those expectations are there and we need to deliver. So just to get into some of the details of how we see this working is the specific administration site, for example, would have designed their systems to record the current immunization that is based on ISO TS5384, but also IDMP, that it's consistent with IPS. We want to keep everything as aligned as possible within what we're doing, and that it also uses some other standards that are for, say, subject or client and provider. And it does that by providing some mappings and of course the data elements themselves. And this is just showing it from a FHIR profile perspective, and it pretty much says the same thing, and I'll just keep moving just to respect your time. And again, the approach is different ways of looking at the same approach. We have the IPS, we have the need from the vaccine capture and collect, document. And I think what we're, again, proposing is an immunization international patient summary that could be transformed to a digital certificate. So back to where we are, where we have these different projects, products, assets, standards, sort of trying to collaborate. As I said, there's recognition that there's timing challenges and such, but hoping we can get here where the information that the projects and products that are being developed can be derived from a core source that could be leveraged by the SDOs within their products that could make this be implemented as consistently across the world as possible. And that's the end for me. Thank you.
And thank you, Beverly. Thank you very much. And we've talked about capturing data and managing it. Now, a very important aspect, of course, is to share it. And with that, we have Derek Rich from IHE International will be presenting.
There we go. Sorry about that. I couldn't find my either my mic or my camera icon. Thank you for the introduction, and I'm actually going to follow on very elegantly, I hope, a natural follow on from what Marjorie introduced regarding coding, what Bev introduced regarding coding and content, and start to talk about how we will share this information around. So more, making more use of the communications specifications of our 5 Cs. I do want to underscore that the care guidelines, of course, are important. A really good example of that is that a person who's recovered from COVID-19 in France will get 1 and only 1 dose of a 2-dose course, whereas somebody who has recovered from COVID-19 in Canada will get both doses. So it's important that the LOINC code, for example, for number of doses in the course is part of the data set for a vaccine certificate. And that's because if you get 1 of 1 in France, that indicates that your 1 Pfizer dose, for example, has got you fully immunized. Getting only 1 dose in Canada would mean you're 1 of 2, whether you've recovered or not. I also want to highlight in this slide that there is in health data exchange, we never talk to strangers. And so there's a pervasive requirement for all of the confidentiality specifications that are listed here. I actually have got a less attractive version of of Adelle's journey, but this is one that is faithfully captured from the EU's Digital Green Certificate Initiative. When we worked in our group, what we wanted to do is convey how this story is played out in terms of data exchange. So if you think of pulling on the ends of that loopy path and stretching it out, we now have Adelle's story and the various aspects of it laid out. And we want to talk about the different system actors and human actors that would be participating in her story in terms of the data exchange. So across the top, we've got actors like the subject of care, the subject's digital wallet, for example, if Adelle is going to leverage her smartphone to capture content and convey it, the care provider, the provider's electronic medical records system, a jurisdictional health information exchange, possibly a firewall, and we'll talk about why that might be there, the National Vaccine Certificate Issuing Service, and then a vaccine certificate verifier who may have a barcode scanner. We laid out who these actors are so that we could show what is the sequence of interactions between them. So initially, Adelle is going to present for care at the vaccination site. She has to identify and prove which Adelle she is. There will be a process of establishing that her information is associated to her. We're identifying the subject of care. We might also, in this first step, be capturing some of the information that we already have about Adelle. So here, we hope, is where there might be an international patient summary or patient summary content model of some sort that's returned that tells us why she is in cohort number 1. It's because she has recovered from a kidney transplant and she's immune suppressed. So that's what would happen in step 1. Step 2, let's not pretend that this isn't the most important thing. In step 2, Adelle will have a vaccine administration. And there is information that we want to capture around that. For all kinds of reasons, we need to know which brand it was, we need to know what lot number it was, and all of those data elements that the GS1 team takes care of coding for us. This information is captured in the provider's EMR, and it is shared to the Health Information Exchange. Again, here's a good example of why an IPS might be leveraged. That could fit very well into the patient's summary data model. Interestingly, there is now content that is conveyed possibly outside the care delivery network to the issuer, to the certificate issuer. And that doesn't need to be the full health summary for Adelle. That instead could be the subset. And as Beverly was describing, there are specifications that we can develop that subset an IPS, for example, to say what's the information that should be on the certificate. And I think I had created a slide to remind me to point these things out, but I didn't forget, so let's move right along. Now, in this next step, we have to issue a certificate for Adelle. And here's where there are some important things to note. One of them is that it is going to be a subset, but not only do we have to have direct specifications regarding the content, regarding the coding, but here is where we will have to establish trust, and we'll have a presentation on that following, hopefully not too long if I keep my pace up. This is where the party that is purporting to sign this certificate, that we can establish after that it really was that party. So I'm Canadian. We would, for example, think that the Public Health Agency of Canada would digitally sign this certificate, or for example, the same government department that issues our passports would sign this certificate. Notionally, when Adelle presents for, she purports to have a claim of vaccination status and she wants to present her credentials to a verifier, she can leverage the artifact that she downloaded into her digital wallet. In terms of what's being done in Europe, that would always be a digitally signed QR code. And there could be now a 100% offline verification of that digitally signed QR code, because the verifier could, in an offline process, have downloaded the public keys of the issuing parties that they trust. For example, the public keys of the EU countries that are able to issue certificates under the Digital Green Certificate program. That is intentionally a 100% offline verification step because of the GDPR requirements within the EU. I've been, for the last number of months, an advisor to WHO on the WHO's Global Smart Vaccination Certificate program, which has just been renamed DDCC, the Digital Documentation of COVID Certificates. It does include vaccine certificates, but will also be including, as the DGC does, lab results and proof of recovery from COVID-19. But in a lot of places in the world, there would be a paper record into which information could have been handwritten. The WHO's specification is calling for there to be a barcode on the front of a paper card, and that barcode could be used to navigate to an online service. Brazil and Nigeria are good examples that of countries that are going to adapt that process. So is the entirety of the African CDC favoring that idea that there would be a coded ID that could be leveraged to go to the issuing service and do an online verification. In many low resource environments, it's going to be much simpler to be able to operationalize that process. Well, I mean, how are the standards used together to support these use cases, these ideas of different parties sharing information between them? I think that this example of the IPS is a terrific one. So let's step through that. We have a logical model for the IPS, and both SEN and ISO have balloted their standards regarding what is the content that would go into an international patient summary. We now have implementable models. There's a CDA implementable model of that HL7 has created. There's a FHIR implementable model of the IPS that's been created. These implementable models say, well, it's good that you've got this content that you've described, but we have to unambiguously identify how that content is going to be coded. And so the SNOMED GPS and LOINC and other code systems, in some cases ISO code systems for dates, for example, are part of those implementable models. I also was a helper on the work that IHE did to create a conformance testable specification for the IPS, so that a digital health solution that purports to be adhering to this standard could be in fact tested and could demonstrate that they do faithfully operationalize this standard. It's very important that the work, again, that I've been involved with WHO, we have subsetted the IPS to create a data model, a core data model for what would be in the Smart Vaccination Certificate, or the DDCC as it's been renamed. CDISC has done the same. They've got a subset of what would be in an overall health summary that would focus on this vaccination certificate. ISO has done that, as Bev was describing. This subset also includes some of the codes that you would need around what is that vaccine and who was the provider organization and where was that administered. And this is where GS1 helps us. So there are a number of vaccination certificate initiatives that are leveraging a subset of this IPS. I actually am not going to stop for Q&A. I do hope that if there are questions afterwards, we can do them at the end. But I want to thank you profusely for listening to my accelerated version of the share portion. And please, this thank you goes out not only to you for being listeners, but also to my colleagues, Jose, Rhonda, and Giorgio, who helped pull this together. And Mike, that's me. I'm done.
Well, thank you, Derek. Thank you very much. And now that we've been through the capture and the manage and sharing, kind of overarching all of that, of course, is trust. And our next speaker is Gary Dickinson from HL7, and he's going to walk us through this aspect of our journey.
Okay, thank you, Mike. I'm Gary Dickinson. I serve as the Executive Director at EHR Standards Consulting. I'm also a member of HL7, actually co-chair of the HL7 EHR work group. I've been an HL7 member, active member since 1989. I've been an active participant in ISO TC 215 since 1999. Let me see if I can find the right slides to show you here. All right, I get into presentation mode successfully, which I can't seem to see the right, find the right button here, sorry.
You may go up on the slideshow, yeah, here, and play from start, file link.
Okay, sorry for the hiccup there.
Right.
All right, so I want to address I actually have two slides, so hopefully we'll get through this relatively quickly. In terms of the looking at security, trust, and record management kind of as a bundle, one of the things we did in ISO is to develop a standard focused on trusted end-to-end information flows. The standard actually came out originally in 2004 and was updated in 2018. Essentially, we're looking at information as it flows from its source to its ultimate point of use. That may be within one system or it may be across systems, including multiple interfaces, interface hops, exchange hops between the source and the ultimate point of use. And then we've built basically a model in there that talks about record entries within a, say, an EHR record, and those records or those record entries are then managed throughout their lifespan. And within that lifespan, of course, are multiple life cycle events, starting at the point of origination and ending along one path at the point of access and use, or if you follow a different path to the ultimate point where that record entry is no longer retained actively within the system. Either it's archived or it may be deleted for whatever purpose. And so that basic construct of record lifecycle has now been incorporated also in ISO HL7-10781, which is the EHR system functional model that is currently at ISO as release 2, which was published in 2015. HL7 actually has a more recent version, release 2.1, that came out in 2020. And we also have now established a implementation guide within FHIR that is part of FHIR Core R4 that is known as the Record Life Cycle Implementation Guide. So these three standards essentially have been harmonized in terms of record management, including characteristics of trust that are managed across that continuum of the lifespan. Now, if I can get my slide to advance, there we go. All right, so what I've tried to do in this graphic is to get something off the screen there. Okay, is to basically go through Adelle's vaccination story, which you've heard about from the previous three speakers, and starting with the point where Adelle presents at the clinic. At the scheduled time, her identity is established, she is assessed, and she receives the dose from the nurse. So in the next column, then of course, we're tracking what's actually happening in terms of the record keeping part of this. Record entry is created for the assessment that occurred and also for the vaccination. If we move on over to the security and trust column, we see that the system itself was authenticated, identified, and authenticated. The clinician, in this case, Charlie the nurse, was authenticated and identified, and the patient, of course, themselves was also identified. And then moving on to the next column, we have provenance, the basic capture of provenance associated with the actions, events that are occurring, who is the system, who is the clinician, who is the patient, what action was taken, what actions were taken potentially, when those occurred, where the physical location, then of course also capturing the device ID and network address where that occurred. And then our final column we have was an audit event created. And of course the audit event could be an internal system functions, which most often it is. It also could use a public journaling technologies such as blockchain, of course, recognizing that in a public journal such as blockchain, you would typically not include anything that would be PHI. There may be transaction IDs and dates and times and those kinds of things in that kind of a public journal. And that is not widely done at this point in time, but it is something that could be considered for the future. Okay, moving on then, of course, the details of the vaccination administration are recorded within that clinic's local EMR system. And so there's a record entry action, which is occurring, capturing that information in that data store. The entries are likely encrypted at the point in time when they're committed to that data store. And then of course, provenance is included, and there's likely to be an audit event associated with that action. Moving on within Adelle's story, we look at the next phase here is that the vaccination administration record is also updated to a shared health record repository, which may be something like an immunization information system. In the US, that's typically done at the state level. So there's basically 50 of those across the country. It's done different ways elsewhere. So we look at this in terms of the data coming out of the source or sending system, the clinic system, where entries are typically transformed from the source representation to the exchange artifact, whatever exchange artifact might be used for this purpose. It might be an HL7 message, it might be a CDA document, it might be a FHIR resource, it might be something else. But typically that content is transformed into the format and representation of that particular exchange artifact. Now, of course, this often raises the challenge of data being, of errors occurring alterations occurring, omissions occurring, or disjunctions between the source data and the exchange artifact requirements. So that's a point of concern. As we look forward, there may be ways to get around to circumvent that. There certainly are at the present time. Oftentimes the original content in text form often is sent along in that exchange packet, so that not only do you have the transformed content, but you have the original content as well. And then, of course, in terms of our security and trust actions at that point, we see that the artifacts are encrypted and the receiving system is authenticated before the transmission occurs. And then, of course, a secure communication channel is also ensured before the communication and exchange occurs. And of course, there is provenance associated with that, because now we've actually created a new artifact, which is the exchange artifact, which has its own unique set of provenance, which is different than the provenance that would have occurred at the originating event back here in the first step. Then, of course, on the receiving side of the shared repository, the entries are transformed from the exchange artifact back to or to the receiver representation, whatever that may be, and then the entries are retained within that repository system. We see again that the exchange artifacts are decrypted once they have been received, and the entries then encrypted as they are committed to the repository data store. And again, there is likely to be provenance associated with that, because the new entry that went into the repository data store has, again, its own unique set of provenance information. And each of those, of course, we would consider, likely consider to be auditable events with an audit trail entry captured within the systems that are occurring here, and again in the public ledger if that is being maintained as well. Then, of course, we're looking at Adelle in the final step here of the clinic visit, that Adelle receives the printout of the details of her vaccination, and then an appointment is scheduled for the second dose, noting, of course, that our particular scenario did have the 2-dose regimen. Moving on, then the second act actually is for the second vaccination, where one could consider that essentially all of these same steps occur over again, with the notable exception that there is likely not a subsequent appointment, at least for another vaccination in the series, since you now completed 2. Then we go on to the next phase of our scenario of Adelle's vaccination story, where she visits a public portal operated by the National Public Health Authority, or wherever that resides in her case. She requests a digitally signed QR code, which she downloads to her phone as a PDF. So again, we go through the steps of accessing that previously, the 2 entries that comprise her vaccination history. Those are digitally signed, and then the QR code is downloaded to, in this case, to her patient, to her phone in PDF format. And so again, the security and trust actions associated with that, we make sure we authenticated the system, we make sure we authenticated Adelle and appropriately identified her. We use the QR, we digitally sign the QR code, we authenticate the device to which this will be sent, and then, of course, we make sure we have a secure communication channel to transmit that. And again, there is now a new artifact that has been created, being the digitally signed QR code, and it has provenance associated with it. So likely then, of course, that would be recorded as well. And then as part of that entry, and then there would be an audit entry as well. And then ultimately, Adelle is asked to present proof of her vaccination status. And for that purpose, then, of course, she pulls out her phone, brings out the digitally signed PDF with a QR code, and that is displayed and verified by the whatever app is set up to do that on the receiving side. And that's basically the end of our scenario. So thank you for your time.
And thank you, Gary. Thank you very much. That whole notion of the overarching, ever-present imperative of trust is very important. And the last segment of our webinar today is implementation. For that section, we have Dr. Nilima Karapanini, who is a lead clinical digital analyst at the MITRE Corporation. And Nilima, you have the screen.
Excellent, thank you. I'm just going to share my screen here. Okay. All right, well, thank you all for having me today. My name is Nilima Karapaneni. I'm with the MITRE Corporation. We are a US-based federally funded research and development not-for-profit, and we work on systems engineering projects for the public good. And one of these has been the advancement of the Smart Health Cards framework in our work with the Vaccination Credential Initiative, which is what I'm here to discuss with you today. This initiative has been a coalition of a number of voluntary public and private organizations. I think we have over 500 organizations participating now who have coalesced around the Smart Health Cards framework. Smart Health Cards are an open standards-based interoperability framework that is designed to get digitally signed, verifiable health information into a consumer's hands in a way that is controlled by the consumer and with a focus on privacy and equity. The developers of this framework kind of saw an environment in the US at least where commercial entities were jumping into this space and coming up with closed systems, proprietary systems that would require you to use their products specifically and did not have a good focus on privacy. So this is the problem that they were seeking to solve with this particular framework. The specifications are freely available, and everybody who's participating in this initiative has committed to validating these credentials without any sort of pre-arrangement, without requiring contracts between the issuer of the credentials, the holder of the credentials, or the verifier of the credentials, without any transaction costs. Collaborating partners in different spaces, some nonprofit entities, EHR vendors, health information systems. Oops, sorry, I lost my connection there for a second. Payer organizations and non-health tech related companies as well. And as I mentioned, all of the organizations who are participating in this initiative have committed to implementing the standard in an open way and allowing people to use the digital wallet of their choice, and also to provide these credentials in a paper, PDF, or QR, digital QR method. It says over 300 participating organizations today. I think this is a little bit of an older slide. I think we have over 500 participating organizations now. We have a number who are still working on their implementations who have not made them live yet. Our biggest issuer so far has actually been the province of Quebec. I think they've issued over 2 million of these credentials to date. And more recent news is Apple announced this week at their WWDC conference that they are going to be supporting Smart Health Cards within the Apple Health Wallet application. The key principles of the initiative, as I mentioned, open standards-based technology, we're trying to operate in a transparent way. And in fact, all of our specifications are available openly on the internet. And in fact, the source code is also available within GitHub, the code repository. If you find a typo or something, feel free to submit an issue there. We will take care of it. And we are also being rolled into HL7 for a governance framework for us. The Public Health Working Group has been really instrumental in getting that process off the ground so we can be formally balloted, hopefully, with the next balloting in September. The other key principle is privacy by design, and the Smart Health Cards framework is based very closely on the World Wide Web Consortium's verifiable credentials specification, which itself takes privacy into as a top concern, essentially. And that verifiable credentials framework is designed in a way that the different actors in the flow, the issuer, the holder, and the verifier, are not able to track a consumer's movements if they follow the appropriate flows. And then flexible and equitable, we did consider paper forms to be a sort of first-class player here. So people without access to mobile applications or with low technical literacy, we did want to make sure that there was a paper-based way for them to participate. And then, as I mentioned, I think that's not on this slide yet, but we are coming under the government's framework of HL7. And we've seen this flow, I think, essentially before in different formats. We have the issuers who are the data sources of the immunization data, who would be producing these verifiable credentials, either as a paper PDF format, a QR code, a file download, or via a FHIR API, and which could be held in any digital wallet application, and then could be verified by whoever needs to verify, whatever organization needs to verify it. A word on scope here. The Smart Health Cards framework does define how to verify a credential, but it doesn't define the logic or clinical algorithm you would need to decide if a person was passing your rules for being appropriately vaccinated or having a negative COVID test. That we're leaving up to the verifiers to decide. It might depend on your jurisdiction. It might vary from country to country. It might even vary based on the business logic of whatever entity you're trying to access. So that is out of scope for this particular framework. And I'm going to briefly show the two specifications that we've developed as part of this initiative, the Smart Health Cards framework itself, and then also the data model, which is the vaccination testing FHIR implementation guide. And we have some links down here at the bottom for these two specifications. This slide is a bit old as well. The thing I would mention here is the trust framework. This is sort of an issue in particular for United States entities. The framework itself was designed to have a decentralized infrastructure. In the US, there's no centralized registry of vaccination information. There's no centralized patient identifier or person identifiers. And the US government has basically come out and said that they do not want to get into the business of vaccination credentials or vaccination registries. So for that reason, we came up with this decentralized infrastructure where all the information you need as a verifier is in the card itself, is on the QR code, and there's no central registry of these cards that the issuer has to maintain that the verifier needs to go back to and retrieve information from. And I'm going to show these specifications briefly here. Okay. So our actual Smart Health Cards framework specification is at this URL, smarthealth.cards. The technical link will take you, sorry, Zoom is being a little bit weird here. It's not letting me get to this tab. Okay, there we go. To the online specification here. And I'm not going to get into too much technical detail about this specification. I will say, from a technical standpoint, this is actually a fairly brief and simple to understand specification. It is, that's a function of a few things. One is that we based it on pretty well-known, understandable technologies, including JWS signatures and public key infrastructure. We did get some pushback from various stakeholders saying, why are you using these technologies? There are better technologies out there that will support things like selective disclosure, which is a privacy feature that allows people to disclose only certain pieces of information from the health card. Like, say you wanted people just to know your name, but not your birth date. You could use selective disclosure to do that. But it does require some newer technologies that people just aren't as familiar with. So for the sake of implementability and expediency, we decided to go with some of these well-known technologies that pretty much everybody in the industry is familiar with. The other thing that makes this a fairly simple specification is that it is a generic specification. It is not specific to the vaccine use case. It is designed to be able to handle any health information that needs to be digitally signed and verifiable. The actual data model for the vaccination use cases for COVID-19 live in a separate specification, which is a FHIR implementation guide. And then, as I mentioned, there's decentralized infrastructure. So there's not a lot of infrastructure architectural detail in this specification. Even though this is a generic specification, there are some guides that it requires for the data models that you might use for different use cases. One is because it doesn't support selective disclosure. The suggestion is that the data models only include the absolute minimum amount of information you need as a verifier. So when we designed the implementation guide for these data models, we left out a lot of information that you might see on other vaccination data models. For instance, you don't really need as a verifier to know the name of the person who administered the shot. That's not critical information for this particular use case. So a lot of that information was explicitly left out. And then the data models also have to be minimal for the purpose of being able to fit all the data into a QR code. As I mentioned, these are decentralized. This is a decentralized framework, so all the information needed by the verifier has to be in that QR code. So we are limited by the number of bytes of information that you can put into a QR code. And then the actual implementation guide is at this URL here on the FHIR.org website. This is a pretty standard FHIR implementation guide, and right now it supports the use cases of vaccination credentials and then also laboratory credentials. We didn't initially design it with the recovery credentials that both the European and the WHO model includes, because we didn't hear from a lot of verifiers at the time that they were interested in that use case, but we are planning to add it in a future release. The other thing I want to point out here is that we have two sets of profiles for every data type, essentially. We have a core profile and then also a data minimization profile. The data minimization profile includes the sort of minimum amount of data you need to actually be able to do like identity binding and validation and validation of an immunization status or of a laboratory testing. Whereas the allowable data profile or the core data profile allows some additional data in there if you need it for a use case that doesn't exactly fit into the one that we designed the profiles for. We are sort of in the process of expanding these profiles to better work for international use cases. You know, for example, we kind of disallowed identifiers on purpose for the US use cases because it's not really a necessary item, and for the privacy purposes, we didn't want to allow it, but we understand that a lot of international use cases, they do want an identifier in there. So we are kind of in the process of making this more international use case friendly. And then we have separate profiles as well for COVID-19 and generic use cases, but primarily because we want this to be ready for, you know, the next pandemic, I mean, knock on wood. Yeah, I think those are kind of the big points that I wanted to cover with everyone today. The only other thing I think we can take a look at is the terminology. This is another thing we've been struggling with a little bit, and there are people on this webinar who have much more experience with this, so I'm not going to talk too much about it. But in the process of we started with the CVX codes, which is the United States CDC produced data set for vaccine codes. And we are kind of in the process of trying to, again, make this more international friendly. HL7's been helping us, the Public Health Working Group has been helping us with this process quite a bit. So this is somewhere we would love to see feedback from people on this call and international people. If you want to reach us, we're at vci@mitre.org with any sort of feedback. So I will close with that.
Thank you, Nalima. Thank you very much.
You're
And
welcome.
we have a couple minutes left. Are there any questions? You can enter them in the Q&A. We might be able to take one or two. Christian, do you?
I see no question yet.
Okay. Type quickly.
People can also raise their hands if you want to speak eventually. But it looks like everything was crystal clear.
Well, fair enough. Well, actually, we only have a minute left. So let me take this opportunity to thank all of our presenters, thank all of the participants that are on this this morning and afternoon and evening for some, and point out that the Joint Initiative Council is here to work on this and other areas. And please be involved and take a look at our social media events and our website, and be involved in whatever way you feel is appropriate to help us make standards more useful, more consistent, and ensure safety, trustworthiness, and appropriate sharing and resharing. So again, thank you all for your time today, and we look forward to seeing you in another venue. Thank you and have a great day.
Thank you.